We are going to describe a reflection on the coordinate plane in this example. Our question is, what reflection rule maps triangle KLM to its image? So remember, KLM is the pre-image, it's the before. K prime, L prime, M prime is the image. So what reflection rule took this triangle and mapped it over here? What we're trying to figure out is that line of reflection. So I know that the line of reflection is going to be somewhere in here. I could, just draw in a sketch of it, but we need to be accurate. So there's a mathematical way to do this. So this is going to get a little bit mathy, so let's just buckle in and be excited for it. When you need to find that reflection line, we're just going to follow a few steps. So step 1, let's write the coordinates of the pre-image and image. So our pre-image has points K, which is -3, 5. L is 1, 3. And M has coordinates -5, 1. So we can just look at our little graph on the right and get those ordered pairs. Now that's the pre-image points. The image points, K prime has the coordinates 5, -3. L prime has the points 3, 1. And M prime has 1, -5. So that's step 1, is just writing out the coordinates of the pre-image and image. Step 2, so if you notice, we have kind of drawn in some dashed lines connecting our pre-image and image points. So we're going to find the midpoint of these segments. And honestly, we have 3 segments. We only need the midpoint of 2 of them. If you recall, when a point gets reflected across a line of reflection, that line of reflection is a perpendicular bisector. So the line of reflection will go through the middle of that line connecting the image to the pre-image to the image. So we're going to find the midpoints. And we only need 2. So let's start with finding the midpoint of, let's say, segment K prime. So I'm going to use, here's my K and K prime. I've got the ordered pairs right there. So if you recall, we have found midpoint before. That's where you add your x's. So -3 plus 5, divide by 2 to get the middle of that. Then you're going to add your y's, 5 plus a -3. Divide that by 2. That ordered pair will be our midpoint. So -3 plus 5 is 2 over 2. 5 plus -3 is 2 over 2. And this will simplify to 1, 1. So the midpoint of segment K prime is 1, 1. By the way, you guys don't have a ton of space for this, so write small in your notes. Maybe for my next group I will give them more space, so sorry about that. Okay, we need one more midpoint. So we just found the midpoint of K prime is 1, 1. So here's where that is. I can see that's on the line, and it looks like it's right in the middle. Mathematically, we found that it is. We just need one more midpoint. So how about if we do the midpoint of segment M prime? We have those ordered pairs right here. So to find the midpoint again, we add our x's, -5 plus 1, divide by 2 to find the middle of that. Add your y's, 1 plus a -5, divide by 2 to find the middle of that, and then just simplify. -5 plus 1 is -4 over 2. 1 plus -5 is -4 over 2. And then this will reduce to the ordered pair -2, -2. So -2, -2 on the graph is right on segment MM. So we're looking good. Now step 3. Is we're going to write an equation through these two midpoints. So we're going to write an equation that will connect 1, 1 to -2, -2. When we write an equation, we need the slope. So first we're going to find the slope of those 2 points, y2 minus y1 over x2 minus x1. We get -3 over -3, which reduces to a +1. So our slope is +1. When we write an equation of a line, y equals mx plus b, we just figured out the slope. What we don't know is the y-intercept, so we're going to use one of our ordered pairs. Maybe I'll just use that ordered pair 1, 1, because that's going to give me an x and a y that we can plug into our y equals mx plus b. So let's go ahead and plug in this information right here into our y equals mx plus b. The y coordinate is 1 equals, our slope was 1 times the x coordinate of the ordered pair is 1. So yeah, look at that, we got a bunch of 1s we're working with, plus b. So 1 times 1 over here on the right is 1 plus b. Solving for b, we will subtract 1 from both sides. So b is equal to 1 minus 1, which is a 0. So our slope-intercept form is y equals, our slope is 1, here's our x, plus our y-intercept of 0. So this simplifies to just y equals x. So we just found that our reflection line is y equals x. And if we look back up at our picture, y equals x goes through the origin because the y-intercept is 0, has a slope of 1, up 1 over 1, and then backtrack the other way. I can see that is going through both of those points, those midpoints we'd identified. And here is what our reflection line is. So it says we were asked to find what reflection rule maps triangle KLM to its image. So the transformation, we'll just write out a nice little sentence here. The transformation is a reflection across the line y equals x. So that's what we found. We found that reflection line right here. The reflection rule we can write this 2 ways. We can say we've got a reflection across the line y equals x of triangle KLM will equal triangle K prime, L prime, M prime. Or we could write the reflection across line M of any coordinate xy will equal, now if you notice up here, see how our pre-image had -3, 5, and the image was 5, -3. So it took those numbers and they switched. Same thing happened here. You had a 1 and then a 3, and then it switched to a 3 and then a 1. So what that looks like in a reflection rule is if you have x then y, then when you reflect across that line, the y number would go first and the x number would go second. But because we just said line M, we do have to say where M is the line y equals x.